Hi, in this video, I will explain what is a Cartesian coordinate system, what is a polar coordinate system, how Cartesian and the polar coordinate system are related, and what are the applications of the coordinate system. First, so what are the polar coordinate system? In mathematics, the polar coordinate system is a two-dimensional system in which the each point on a plane is determined by two things. One is the what is the distance from a reference point, and at which angle it is what angle. See, for this point, if you take, so this line is called the reference line, and this y is called the origin or the pole. This point is decided by two things. One is the distance, the other one is the angle. So it is at a distance 3 units from the origin, and it is at an angle 60 degree from the initial line. This is called it as initial line. Next, what is Cartesian coordinate system? This is, we are all familiar with the Cartesian coordinate system. That is, we'll take x-axis and y-axis. Any point on this plane will, suppose if you take this point, it is at a distance of 1 unit from x-axis, 1 unit from the y-axis. Means any point in the Cartesian coordinate system, it will be decided by the distance from the x-axis and distance from the y-axis. So moving on to the polar coordinate system. So this is how it looks like, this polar coordinate system. So like this is the initial line, 30, 60, 90 degree. So this is the angle, and you can also distance also you can consider it, distance and the theta. So next, the polar coordinate system is formed by fixing a point. First, we will fix a point, and then an axis called the polar axis. This is the origin or the pole, and this is the initial line or polar axis. So then, uh, a point P. Each point in the plane can be assigned polar coordinates, that is r and theta. P is equals to r and theta. This r is what? R is the directed distance from O to P. This distance is the r. And this angle is called theta. Theta is the directed angle, the counterclockwise direction from the polar axis, from here to here. This is how we'll represent the uh, any point in the polar coordinate system. Now, how to relate it? So how to relate it? Now, so this is the polar axis or the initial line. This is a point. So this point has two coordinates. X, Y is the Cartesian coordinate system. R and theta are the polar coordinates. R means it is the distance from the origin. Theta means it is the angle. Now X, Y means, so it is at a distance x units from the y-axis and y units from the x-axis. Now, how to relate these two coordinate system? So that is given by. So now we'll see the using the definition of the trigonometric function sine theta. We'll use the sine. Sine theta means it is defined as opposite side by hypotenuse. Since this is 90 degree, this is called opposite side, and this is the hypotenuse. That is sine theta is equals to y by r. Similarly, cos theta, for this angle, this is the adjacent side. Cos is defined as adjacent by hypotenuse, that is x by r. Then tan theta. So tan of this angle will be opposite by adjacent. Tan theta is equals to y by x. Now we'll see the how to relate the coordinate system. Cos theta is x by r. That is x equals r cos theta. What is x? It's a Cartesian coordinate. What are r and theta? Polar coordinates. This is how the Cartesian coordinates are and polars. Again, sin theta y by r. Y is equals to r sin theta. You can see on the left hand side there are Cartesian coordinates. On the right hand side we can find the polar coordinates. This is the relation between Cartesian and polar coordinate system. Even tan theta can also be written like this. Now, some of the graphs. See, these are the some of the graphs which may you can find it in the nature also, like these flowers. This is a three leaf and two leaves, and this is like a heart shaped, and like this. This is also similar to the heart shape, and each one has this is called rose, lemniscate, lemacon, cardioid. Cardioid means it's a heart shape. Means these are the some of the examples of the polar curves. So what are the applications? What are the applications of the polar curves? Now let us see. Polar curves in the real life. So butterflies are the most attractive and the colorful insects we have seen. The symmetry of the wings can be explored by using the trigonometric function and a system for plotting the points is called the polar coordinate system. You can see these two butterflies, and this is one of the standard curve. You can see the wings as well as the curve are the same. Means we can explore these type of natural things also by using the polar coordinate system, or we can analyze also. So in continuation, the special types of curves are called the involutes, which are used in gear tooth design to eliminate the vibrations. That is, in designing the gear, so we'll use these involutes. And involutes and evolutes is a very special curve can be used to design a clock. For the in the designing of clocks also, these curves are used. Polar curves are also used to describe the direction of pickup pattern of the microphone. So you know the microphones. We can use this polar curves in which direction this microphone is picking the vibrations or the sound it is picking. So to decide that also we can use the polar curves. So polar curves are also used in the gravitational fields, radio antennas, and also groundwater flow, and all these things we can use it. So in the digital world, means in computers and the cell phones are also will use the coordinate system. So how you can see that a text file or a PDF file, which when open it's an example of coordinate system. Means it is like a text file or a PDF file. It will be a two-dimensional. So two-dimensional means so it is also a coordinate system. Any PDF file which contains text, images, different shapes are placed according to the two-dimensional coordinate system only. So like this is an example. So position of any object. So you can see that this is in a three-dimensional. So you can see A, B, C. Position of any object can also be decided by using the coordinate system. Location of the air transport. So what is the current location of an aircraft? So which is what is the distance and at which angle it is subtended? Like that we can use it. And how much time it is required from one place to the another traveling at a certain speed. So these can also be decided by using the uh, that is polar coordinate system. So polar coordinate system has lots of applications. So we can. Oh, thank you.